Good morning. I'm Rana Dubrow. I'm the Director of Membership and Member Services at CURT. Welcome to our continuing webinar series offered by CURT. Today's topic, Understanding Embodied Carbon and How to Set Performance Benchmarks, is presented by Stacy Smedley. Stacy has a Bachelor of Arts in Architecture from the University of Washington and over 18 years in the architecture and construction professions. Her resume includes the first LEED for Homes Platinum certified project in Washington State, as well as the first project in the world to be certified under Living Building version 2.0 standards. As sustainability director at Skanska, Stacy has led sustainable initiatives and is a subject matter expert in LEED, Living Building Challenge, and carbon emissions associated with buildings and construction. As Executive Director of Building Transparency, a nonprofit organization, Stacy leads the continued management and development of the free, open access, Embodied Carbon in Construction Calculator, EC3 tool, and works to educate and engage the building industry on actionably reducing embodied carbon emissions or building materials. Please feel free to enter your questions in the chat box. Stacy has advised that she will respond as we go along to the questions. This session is being recorded, and the link for the recording, as well as Stacy's slides, will be provided to you in the next several days. And now, here's Stacy.
Good morning, everyone. I'm happy to be here today to do a little deep dive into embodied carbon and the benchmarks that we are seeing get established globally. I'm going to go ahead and share my screen and dive right in. If you have questions as I go along, there's a lot of content. We're going to do a demo of the tool after I get through some slides. Please feel free to put them in the chat and we can manage those as we go. Sometimes it's helpful for me to just stop and be able to answer a question on what I'm talking about. So I'm happy to do that. As was mentioned, we're really going to talk today about first understanding embodied carbon and then how to set benchmarks and really lead to reductions and optimization. I'm currently the Executive Director of Building Transparency, a nonprofit with a mission of providing open access tools and data that enable embodied carbon reduction. And we're doing a lot of work right now across the construction sector with policymakers and private owners to really spearhead this work. So to dig right in, I'm going to start with slides that many of you may have seen already, but it's always just good to ground ourselves again in why we're talking about embodied carbon and what it is. And embodied carbon emissions are really this 11% of emissions that are associated with how and what we build with when it comes to construction projects. So a lot of what we've been talking about over the past 30 years has been around operational carbon, the energy consumption of buildings that we build, where that energy is coming from. That's that 28% of global CO2 emissions you're seeing there. But the building materials and construction sector, what we are manufacturing, things like concrete and steel, how we transport those materials to site, how we install them, demolish them, hopefully reuse them. All of that is in this building materials and construction or embodied carbon piece of the pie. We know that's at least 11%. We actually know that it can actually spill over into transportation and industry emissions when you're thinking about all of the components of getting a material manufactured and installed and put into place. So we know, I now say that buildings and construction are at least 39% of global CO2 emissions, but likely more. And again, just a slide to put this into perspective and pictures. On the right, again, there's the operational energy consumption, how buildings are consuming energy over their life once we built them. Everything before that, and even during that when it comes to materials and how we put them into place, make them, and then replace them during the use phase, and then demolish them, again, is embodied carbon. So it's everything that a contractor touches along their part of the work. And the last way I like to put this into perspective is just looking at it through a different lens, and that's through manufacturing emissions. So if we think about manufacturing emissions being at least 31% of greenhouse gas emissions, if you look at the major sources of those impacts, things like cement, iron and steel, chemicals that we would put into paint and coatings, other things like carpet, make up a huge piece of the manufacturing emissions breakdown. And those, of course, are all things that we build with. And the reason that this bucket of carbon has become even more important is that we continue to build so much. So over the next 30 years, it's estimated that we're going to construct a New York City every month for the next 30 years. If you think about all of the materials that have to be procured, manufactured, installed to make those buildings at that scale, if we aren't thinking about the emissions associated with them, knowing how big a piece of the pie those emissions are, we're never going to get to zero carbon emissions or meet reduction targets that are being established to mitigate climate change. We also now know that globally, on average, if you look at one building, an average building, about 50% of the emissions for a building are in this embodied carbon emissions bucket. So it's equally weighted when it comes to the importance on the building level, on the project level, with the operational carbon that then begins to accumulate over the life of the building. The important thing about embodied carbon emissions, once they are spent, especially the manufacturing emissions, you can't take them back. So that decision point where you're picking the material that you're going to have made for your project is vitally important. And then just to look at the stages of embodied carbon, this is how it's broken down pretty regularly in various global standards in these stages. On the left, you've got the A1 to A3 product stage, how you make the material, extraction of the project of the raw materials, transportation to a manufacturing facility, and then production of a product. The construction stage is the A4 to A5. All of that together is called upfront carbon typically. And that's getting into the A4 is the transportation to a site. A5 is the actual installation of the materials on site into the building or infrastructure project. Further along the line, you get into the use stage. That's how many times you might replace the material, something like the roofing or the cladding or the carpet. And you have to account for those additional emissions of those different replacements. And end of life is all about how we demolish projects, how we hopefully take materials out of the demolition phase in a way where we can put them into new materials, which then reduces the amount of the new stuff that we are having to extract over in A1 again. So it is a circle. That's what circular economy is when you hear that term thrown around. A little bit about how these impacts stack up for materials. If you're looking at something like concrete, you can see here that the A1 to A3 stage, that production stage, that big blue bar is the crux of the impact. If you're looking at carbon intensity per cubic meter of concrete. So these blue bars are just looking at different strengths. And again, that product stage impact is far bigger, even when you add up all of the other stages together. So there's transport, construction, demolition, end of life transport, and whatever you are doing with that concrete, crushing it up, hopefully using it again. But those emissions, again, are very small compared to that product stage. If I look at steel, the same thing is true. So there's the different types of steel that we typically see. And again, the amount of emissions that we associate with that production of the steel far outweigh everything else when you stack them on top. And this is an average impact assessment that we've done looking at global steel. So there's just the kind of the background, all the different terms, embodied carbon upfront, embodied carbon, the different stages where the impacts lie. And I think what's important that I always like to say now is that I feel like we're at a tipping point when it comes to how this data is now being understood and used. And I'm going to go through why I believe that after having looking at this and really working on it now for 5+ years. The first is climate. So we are seeing more and more companies and policymakers focus on climate. That's largely based on what started with the Paris Agreement, where there was a commitment to try to stay under 1.5 degrees Celsius. Just in a few of my Stacy climate slides, the IPCC has put out new reports that are saying we're warming faster than they predicted when the Paris Agreement was put into place. And right now we're at somewhere between 0.8 to 1.3 degrees warming already. And in the scenarios that they put out in the latest report, the best estimate for us is that by midterm, when we're all still on this planet, most of us, hopefully, in 2040, 2060, we're going to be above that 1.5 degree warming, even with the very best scenario in terms of how we're reducing carbon now. So it is urgent and we need to be focusing on it. What's happening based on all of this coming out, as well as climate impacts being felt, is, again, more attention to this and more targets being set. So there are targets being set on both sides. The first is in the private sector. We're seeing large companies like Microsoft, Meta, Amazon, and others set their zero carbon targets on certain timeframes. Meta's is by 2030 across their value chain, which includes embodied carbon. All of these include embodied carbon emissions of their buildings and the materials. Microsoft and Amazon are ahead of the Paris Agreement in the 2040, 2050 time period, all including, again, scope 3, which is where the building materials sit. So they're saying that by that time frame, they're going to have zero carbon in buildings that they are constructing for all of their uses. There's also a slew of public policy, and this is where you get into benchmarks and baselines. The Carbon Leadership Forum has a great map that talks about this, but this is really just kind of an awareness for the different tiers of policy. This kind of policy around embodied carbon, whether it's product stage or building level, can be at the city level, the county level, the state level, the national level, or the global level. And we're seeing that now. I'm going to walk through some of those examples of what those policies and benchmarks look like. So the first one is the city of Vancouver. What they are doing is setting whole building baselines where they're looking at the carbon emissions of a whole building and how it's made per square meter. They're requiring reporting of those emissions using a whole building life cycle assessment tool, which I'll get into a little bit later. And then it's including all stages. So this is an example of a whole building approach where they're wanting to show reductions against what I call a building carbon intensity, or a carbon CO2 per square meter of building. It's very similar to an energy use intensity for operational energy, where you have a kilowatt hour per square foot per year. And embodied carbon language, you're doing a kilogram of CO2 per square foot or square meter. So that's at the city level in Vancouver. In California, they've implemented the Buy Clean California Act. This looks at different materials, things like structural steel, rebar, glass, mineral wool insulation. And what they're doing is at the product level, setting requirements for disclosures through environmental product declarations. Those are third-party verified product level accounting of the carbon emissions per unit of material. So you can see over here on the right, what they're doing is setting a limit of how much carbon can be per unit for these different products. This means that any public project in California has to use materials across these categories that have these EPDs. The manufacturers have invested in that transparency and then prove that they're under these limits, and that is implemented. At the county level, up here in Seattle where I sit, this is a county climate action plan for King County. They're requesting EPDs for concrete by 2022. So this is, again, very product level. And then requiring the EPDs by 2023. And then by 2024, establishing, again, a maximum kilogram of CO2 per unit of concrete that manufacturers have to be under with their mixes. And they utilize EC3 for compliance there. That's the tool that we manage. Again, at the county level, this is a Marin County code down in California for concretes. Again, I think hopefully you're seeing a trend here on the product level. It's requesting these EPDs for reporting and then setting limits for the carbon intensity per cubic meter. So again, the same process, each jurisdiction is just setting their limits based on their data. On the private side, this is happening too. So Microsoft is utilizing EC3 and CLF baselines to track and report A1 to A3 impacts, those product stage impacts across a group of material categories, and then requiring a 30% reduction against the baseline at the project level for a stage, again, that product stage. So requiring EPDs, setting a limit, and setting a reduction. Certification land, there's certifications that are doing this. So this sets a 500 kilogram of CO2 per square meter limit for the A1 to A5, that upfront carbon stage. This is the zero carbon certification by the ILFI, and allows the use of whole building life cycle tools or EC3 to report those impacts. So again, once you've got an understanding of the stages and you've got an understanding of that whole building approach with carbon intensity per square foot, or the product level approach of EPDs and carbon intensity per unit of material, all of these policies and certifications are really using that as their baseline for setting the requirements. LEED has a pilot credit that's doing the same thing, reporting stage A1 to A3, the product stage again, for the materials that you see on this list, and then giving projects 1 point as a pilot credit as they're testing this language for just doing that disclosure. and the second point for a minimum 30% reduction against the Carbon Leadership Forum baselines. There's many more. Again, all of these things are doing very similar strategies requiring EPDs. This is at the House level, at the federal level for us in Washington, and then at the national level, where you can see again performance targets. This is called by clean policy, largely at the various different levels of government where it's happening, requiring EPDs and setting benchmarks or thresholds that you must be under. This is in the House bill. And then just one note for globally, this is happening also. The United Nations have an industrial decarbonization initiative that we're engaged in, where they're looking for ways to set disclosure requirements, starting with concrete and steel, and then reduction requirements over time. And this is something that member countries could sign on to committing to. So just in a nutshell, what you do in these two different approaches for whole building LCA policy, you require a whole building life cycle assessment. That's where you're looking at all the materials in your project. You're using largely average data to start to set a benchmark project. You're utilizing a tool to show compliance with that. And then you're trying to show that you're under a certain carbon intensity per square meter for your project, getting as accurate as you can with the data within that life cycle assessment model. And those are the tools at the bottom that really support that level of assessment. What this does is allow things like this to start to happen. This is a benchmark study where Carbon Leadership Forum took a whole bunch of these whole building life cycle assessments for different project types, like commercial, residential, and started to look at the ranges of those carbon intensities per square meter. So you could start to understand what's a relevant baseline or estimate could be as a starting point. 500 is really what we typically see in a lot of these places as a, if you're just trying to gut check a project, if you're around 500 or under it, you're about where you should be as a starting point. At the material level, this is again where you are requiring environmental product declarations for a specific list of construction materials. You're setting a kilogram of CO2 targets or limits per unit for those construction materials. You're requiring EPDs for disclosure of that information. You can utilize EC3, which I will show you in a minute, to display the compliant EPDs, and then the projects have to submit their project data to show that they're under those limits for the group of materials that are part of those disclosure requirements. Just a little bit more about EPDs, because it's important that these are understood. These are really where we can get to those product stage A1 to A1 impacts, and where all of these policies are pointing. So they are third-party verified life cycle assessments at the product level. There are ISO and EN standards that are followed to do the life cycle assessment at the manufacturing plant for a product, where you're getting all of the material ingredient inputs, you're understanding where they're coming from, how far they're transporting materials to their manufacturing site, the energy profile of their manufacturing process, any emissions that are popping out, things like cement kiln emissions for concrete mixes. All of that gets accounted for following those standards. There are product category rules that are followed to actually, per product, provides guidance on and requirements for what you must include in the EPD. And then there's third-party verification on top of that by a program operator that basically makes sure that all the standards and rules were followed before the EPD is published. They are like nutrition labels for building materials. Largely, they are PDF documents that are multi-page, but there's this very important and valuable table that can be on page 2 or 8 or 12 that really has that carbon intensity data. So if you think about it like when you look at a box of cereal and you see the serving size and how many carbs you have for your 2/3 of a cup of cereal, if you're on a low carb diet, you're trying to get that carb count down. The same is true for an EPD for a building material. You have a kilogram of CO2 equivalent per unit of material, and you're trying to get that carbon down when it comes to building materials. When it comes to the material, yes.
There's a comment in the chat box here.
Sure.
We have a person who was in a small meeting with people involved on the construction side of our industry discussing this topic, example, EPDs. I said the contractors have a role in reducing embodied carbon, and a couple people said they don't have say in the materials. It's what the designer specifies. I said they could make recommendations to use materials with reduced embodied carbon. It didn't go over too well. What are your thoughts on that?
Yeah, I mean, I agree with you that there is a role for the contractor to play, and I can walk through some examples of that when we get into the tool. But even with the screen I'm on here, what we're seeing contractors do, our major partners right now on the contractor side are Skanska, Turner, Webcor, Multiplex, and Obayashi, and Mercury. So we have got some contractors from all over the world that are now engaging with this. What they are doing is creating carbon estimates using EC3 and showing that to the owners so they can understand that there are reductions that are possible. And then during bidding and procurement, requesting EPDs for things like concrete, where they're looking for 3 suppliers to bid, for instance, and just being able to demonstrate the cost and the carbon emissions next to each other. So you might not be able to say you're going to go with this supplier or that supplier. The owner is going to make that decision. The architect's going to set the basis of design. But just like you get cost data during estimating and during bidding to make decisions, you can have that carbon data right next to it because it's open data that you can access. And a lot of the times in that process, the low carbon bidder is the low cost bidder for things like concrete. So it's a lot about just knowing that you have this information that you can share and that you can provide so that the owner really can make the informed choice at time of procurement. But I have some more salient examples of that as I get further down. You know, I think contractors are our second biggest user profile of EC3 to do that work. And they're the ones that are being required to do this work by some of the owners that are our partners as well. So this is procurement driven, and contractors have a large role to play in procurement. We need to think of carbon just like we think of cost. It's another metric that we include in our estimates and in our bids to make informed cost and climate decisions.
Great, thank you.
Yeah. So again, on the procurement side, which is what we were just talking about, this is an example in the EC3 tool that I'll go into in detail that shows that you can actually get comparisons at the manufacturer level of carbon intensity. You can understand how many mixes or EPDs each supplier has, and then look at the range of carbon emissions for something like a 5,000 PSI mix. So if Cal Portland and Cadman have this many EPDs for their 5,000 PSI mixes, you can start to understand who's got more optimized mixes from a carbon perspective, and you can hopefully ensure that you're getting at least these 2 to bid on your project and provide that data during procurement. So the point of all of this, that as these baselines and reductions are being set and more data is being turned in and submitted to show compliance, what we'll see is both the building level and the product level baselines or limits move down. And that's exactly what's happened with energy code as we've gotten better at designing more efficient buildings. You know, the requirements for how low your EUI is against a baseline building have gone down, meaning that the energy consumption is going down. The same thing is true on the carbon intensity of building materials. As we begin to do this work, we are seeing that manufacturers are competing on this and reducing the carbon emissions of their products, which is what we want. And this is just my kind of cheeky slide deck that I've used before when I'm doing this kind of baselines versus benchmarks. You know, who will win? My son loves the shark versus train book, so I use it as my little analogy. A lot of folks think that it has to be either whole building level or procurement level, and it can't be both. So it's this versus, which one should I do? Or is it a carbon per square meter baseline versus a GWP limit for a product? You know, which is better? It depends on what you're trying to do. There's strengths and weaknesses to both, and they both are important. So we tend to say it's good to have a building level target. So you're optimizing as you're designing, you're trying to use less materials. You're looking at different materials, you know, concrete versus steel versus timber. Make those decisions, optimize your building, and then look at the materials very specifically and make sure you're procuring the lowest carbon material in each category. So if you do both together, you're really driving the carbon down across the whole process. And neither are perfect right now, and that's okay. So when you're looking at these things, the data continues to get better. The tools continue to get better. We are filling gaps in data as we speak, but we have to start now with what we have because we don't have time to wait for perfection. So that's what's happening with the policies. They're seeing that. They're including materials they know we have data for today on the procurement side. They're starting with high-level benchmarks on the whole building side. And again, we'll get more and more accurate and more specific as more of this data is developed and as more people understand how to do this work. So that's really the end of the slideshow. What I wanted to do now, because this is, I think, largely a construction audience, is just move into the tool, building transparency, to show you how it works. Before I do that, I guess I'm going to walk through a few more slides just to describe the tool a little more. The EC3 tool is a free open access tool that is available to anyone to register for and use. It's cloud-based. There's no download. Sorry about that. The nonprofit was established in 2020, Building Transparency, again with that mission of free open access data and tools to host EC3. EC3 came out of a need that I saw in my role at Skanska, to digitize all of this data and put it into a database where we could do carbon estimating. It was seed funded by Skanska and Microsoft, and co-conceived up with our partners, Change Labs. But all of these companies that are now on our board were very early adopters or continued partners that have helped really incubate the tool. It was incubated at the Carbon Leadership Forum at University of Washington with about 50 partners, and then launched into this nonprofit. And now I manage the nonprofit with Skanska support, my salary. Our current partners, I like to show this slide because I'm proud of everyone that is partnering with us to help us continue to improve EC3 and all of our programs now at Building Transparency. But this is important because it's very cross-sectional when it comes to the roles in the construction process and the building process. We do have large owners that are now our major partners in terms of implementing EC3 and requiring EPDs and their use, and really funding the tool to be free. We've got large architects, engineers, contractors that are also our pilot partners that are testing the tool, requiring it to use at various scales and helping us to improve it. And then we have material manufacturers and industry organizations that are also engaging with us to make sure the data in the tool through the EPDs is well sorted, that they have representation in the tool with their members or with their products, and really want to make sure that those categories are publicly available to people. So everyone has a role to play in how we do this accounting. Owners set requirements, architects, engineers set specifications, contractors procure and confirm, manufacturers have to provide the data and decarbonize their products. EC3 today is focused on this product stage. That's because that's what EPDs report most consistently and most accurately, and because of what I showed at the beginning, which is that the impacts are largely in this product stage for major materials. So if we're trying to decarbonize really quickly, we need to decarbonize those production emissions. And that is by having the data available and sending a market signal to the suppliers that they need to disclose and reduce. We are adding A4 and A5. A lot of the reporting that's happening at the owner level and at the contractor level is A1 to A5, this full upfront carbon stage. So the tool will start to enable that A4 to A5 tracking as well later this year. And then again, we're really focused on specs and procurement. Whole building lifecycle assessment happens earlier with those LCA tools that are really trying to optimize the design. We are looking at material categories and specific carbon intensities during spec and procurement to really try to make sure we are procuring the lowest carbon option in EC3. And then just at a cartoon slide, it's better when I get into the tool, but really what we're doing is carbon estimating. So we have a database of these EPDs that's free and open to search and sort. You can compare materials, look at different suppliers and products, and then you can use your material quantities from a construction estimate or a BIM model, import that into the project planner in EC3, and begin to understand where your impacts are across your project, and then show reductions as you begin to pick products. And with that, I am going to go into a demo of the tool. And I please, as I'm doing this, ask questions if you have any, as we start to get into what the tool, how you use it. You can register for free at Building Transparency, just at email address and login, and then you can sign in. So I'm going to go ahead and just sign into my account. And once I'm in the tool, I'll just kind of orient you to how you would engage with this if you were trying to do some work. Sorry, my computer is being a little slow. I might have to use my slide deck. Give 1 minute. Now we can go back to slides. There we go. So now I'm NEC3. What you're going to see first is that I've got my presence in the tool. It's telling me what kind of user I am. But really, the most important thing about the tool is the data. So at the current moment, this is telling us how many of these EPDs we have per material category globally. And if I click over to concretes, you're going to see that we've got a digital process where we're getting mix specific EPDs for concretes. That means we have over 38,000 currently valid concrete EPDs in the US, which is, we're leading here on that. And you can click through this and just understand where we're having EPDs for things, getting into how product specific EPDs, how many we have. You can see again, total we have 81,000 concrete mixed EPDs, over 3,700 EPDs for finishes. In total, we're about 98,000 EPDs in the tool, with concrete mixes being a lot of that based on how many you could have per plant. But if I'm just a contractor or an architect specifying, or even an owner interested in this, I can just go in to find and compare materials. You're going to get the list of all the materials that we have data for. I can click over into Ready Mix. So now I'm in Ready Mix. I'm going to click Next. Here's my screen of all the things I could sort for with Ready Mix. I'm going to put in my strength. That's the most common. There's my cure time of 28 days. I'm going to say that I'm sitting in, today I'm going to pick Colorado. I don't know how much data we have in Colorado. I know we have some because they've got policy. So I'm clicking into Colorado and now search. And it's going to return all of the EPDs for my concrete mixes in Colorado. If I was trying to meet a policy, Colorado does have ByClean policy that requires EPDs for concretes now. And they're going to set a limit you have to be under. What the tool is going to do is tell you you have 309 product specific EPDs for concrete mixes. Here's that carbon intensity per unit that we talked about. Up here, you're going to see this box plot that's giving you that, that kind of range of what's happening with all of those EPDs, carbon intensity per yard. And then if I scroll down, these are all the EPDs. So there's the manufacturer, Burnco, that's the plant, that's the mix ID, there's the carbon intensity per unit. If I click compare over the manufacturers, it's going to show you that comparison graph that I had popped up in my slides. Here are the 4 suppliers that in Colorado that currently have EPDs. Here's how they're performing from a carbon intensity perspective for all of their concrete mixes of that strength. So what this is showing right now is that Flatiron looks like they're optimizing their mixes better when it comes to carbon, just out of the gate. If I was a policymaker, I might say, okay, this is the 80th percentile of the data. We have outliers up here and down here, but if I set a limit at 350 kilograms, the major suppliers that are currently disclosing can meet that limit. If I wanted to set a target, maybe I would look down at the bottom of these box plots and see if we can get around 280, 270 kilograms per unit for the mixes that are disclosed. So that's very broadly when it comes to target setting or benchmarks to understand where you are. This data, as it gets more robust, begins to let us do that across different industries and products. So I'll do this for Washington because there's a good story there for concretes. In Washington, Microsoft and Skanska have been requiring this type of data for the big project here, and it's been a couple of years now. But if I search for Washington concretes of that same strength, what you're going to see is that a couple of the suppliers are really pretty aligned in their optimization and are tending to be lower at this point. And that directly correlates to their work to optimize their mixes for these requirements for the projects that have been in place. So you're in Washington, you're going to see the high end of a couple of these suppliers is down in that 280 range, which was in the low end of what's happening in Colorado. This is largely because of things like them going to Type 1L cement, because they know that carbon is now just as important as cost for some owners or contractors. And now other suppliers are beginning to look at how they can optimize too. So the average emissions in Washington have gone down about 18% for these suppliers in the past 2 years. So that's really how you can do the comparisons. You can also compare at the mix level. So if you knew you had mixes from these different suppliers that were in a bid that were comparable, you could start to filter that in the tool. And at the mix level, I'm just picking a couple randomly. You'd be able to see there's Stoneway's mix and there's Cadman's mix. You have the mix ID, and that if you had a choice in your procurement, that Cadman's mix would be a lower carbon mix. And again, I picked those at random, but you could get as accurate as you needed to with your mixes and your suppliers. You can do this for any of the material categories. So the same thing is true for steel. I could just look at US Let me go into rebar, actually. Same thing. I could go in and I could just look for US suppliers of rebar. And I could begin to understand who's disclosing and who's the lowest carbon option by plant. So there's me doing it by manufacturer. You can see the range, like here are all Nucor's plants. There's one that's really low, there's one that's really high. I wanted to understand which plant was the lowest for my procurement. I could just filter to Nucor. And then I could compare by plant. And now it's going to show me Nucor and their Seattle plant's the lowest right now. And that's really based on the energy grid here. But that's a level of kind of detail you can get into when you're trying to dig into this data and use it. The other features of the tool, real fast, are the building levels. This is where you could do that carbon level estimating at the building level. So if I just go to public buildings, this is where you can add a building project, start from scratch. You can import from BIM, and then you can build a project. And it's going to show a house to be simple. But here's a house, you're putting in the type of project, the square footage, the construction start date, the location. If I scroll down, what you're going to see is this very much looks like a bill of materials estimate, where you can have your description, your quantity, and your unit. But instead of cost data being here, what you're seeing is the carbon intensity of each of these things. And that is very much through the same thing I just showed you, where you can go into the searches. You can search by radius or by geography, get to the collection of data that you want to use to understand what's possible for the carbon intensity of your concretes, and then even select an EPD to see how your actual EPD, your product, is comparing against that range of what's possible. So that's really what the owners and even the contractors are doing. Even the designers, they're using this data to set those, again, project level carbon intensity targets. What's possible? What am I realizing based on the products I've selected? And then reporting this number to meet their reduction targets that they've established. There are charts that help you understand this data, where you can actually dig in on the left over here. This is saying the carbon impact of my concretes and my sheathing panels comparatively to my glass doors and composite lumber. It rolls it up to the different components of construction, shows you the impact of basement construction, tying back to the concretes. This is really just helping you understand where your hotspots are. If you're going to pick a couple of materials to reduce or set procurement requirements around, you might want to do it for your concretes and your sheathing, really understand what those emissions are coming from. It rolls it all the way to a project level accounting over here, where you can start to set targets and really see what's possible. And then the last thing, just for the construction lens, we do have a level bids form where you can create a bid sheet. And I'll just pick carpet just for fun. You can create a bid sheet, and this is where you set it up for a project. Down here, you can put your different bid items, the quantity of the product you're talking about. You can say that I've got an EPD for this one from this sub, it's for this interface carpet. My second one's Tarkett. My third one is J&J, and you can put in the costs. So I've just put in random costs here as an example. What it's going to do down below is show you, and this, of course, they have very small carbon contents compared to the costs, but show you where they fall both from a carbon and a cost standpoint. If I reduce this cost, because maybe this is ridiculous for the amount of carpet, you're going to see these graphs change. But again, you can actually export this bid leveling sheet and have that data available, just like you could have cost data available. So in this case, interface is the lowest cost, and they have a carbon sequestering carpet tile, so they're the lowest carbon as well. And this is how you can download that as an Excel file. This was a feature that the GC has actually asked us for, to be able to start to show this data next to cost. So there's the cost, there's the carbon content for each of these products. I think I will stop there. I know it's only 8:40. There's typically questions. I don't know if there have been questions in the chat.
Yeah, there are some questions, Stacy. Thank you. One is, can you give an example of what some of these companies, let's say concrete suppliers, are doing differently from the others in order to reduce the embodied carbon, other than just the documentation of the output?
Yeah, so the way that this is being really implemented is at time of bid, the GCs are giving the suppliers performance specs for the mixes. So they're not They're not indicating like a maximum cement replacement or any of those things that would limit how they could mix the ingredients. They're just saying you must meet these performance requirements, which structural engineers have said these are the ones that must be set. So it's strength, it's cure time, it's some of the other things that come just as performance metrics. And then there's telling the concrete suppliers to optimize the mix on a carbon perspective. So what we heard from suppliers when we first started this, when I sat down with the suppliers in Washington wearing my Skanska hat, was that no one had asked them to optimize for carbon, and that they knew they could be providing mixes with lower carbon content just by the ingredient mix that they used at no cost increase. It's just that if no one has asked them to reduce the carbon of the mix, they're not going to try. It's like they're cake bakers, and we're asking them to build a lower carb cake with their mix design. They know they can replace that a little bit more of the sugar and in the cake and make it still taste the same. So that's really what's happened in this first swath is they're just optimizing it. They're doing a little bit more cement replacement. They're looking at their aggregates and which aggregates they're using. And we're seeing about a 30% reduction just based on that optimization of the mix when they're empowered to, and they can then disclose through the EPD. Like I mentioned in Washington, what a couple of suppliers have done is gone to type 1L cement, which is a cement that is about 10% lower emissions in terms of how it's made than typical cement. And that's given them another kind of range of reduction against their competitors. And then we're seeing other things like there's things like carbon cure. There's some other kind of cement additives we're seeing come to market that will help them have more options to reduce even further.
Okay. Question, is there a quality and or price difference for materials with lower EPDs?
It depends. So again, I think on that first range of reduction, what we're seeing across material categories is just by having the data right now with products that exist today. If you've got, all of your carpet options with EPDs at the product level, if I'm picking another kind of wonky example, but a good one, there are carpet tiles now that are almost zero, that are at the same performance level and are competitive to the ones that are higher. And that's just because we're starting from a place where we just need the data to see the lower carbon materials that are on the market today. So there's a good report that Skanska and the Rocky Mountain Institute put out that really shows the reductions possible at no cost increase, and then what that premium looks like. And it really is, again, about 30% across the board at no cost, and then you start to have small upticks as you get into even lower carbon products.
Okay, and here's a compliment. This is great stuff. Any other objections to suggesting reduced embodied carbon products or materials?
I mean, I don't have any objections to it. Obviously, this is what we're trying to support, what I was trying to do at my role at Skanska when all this kind of was being conceived of. What I would say is just that you don't have to boil the ocean. If you want to just go start with one or two material categories and test this out, the data is becoming more robust and is there, and you're not having to require anything. All you are doing at the start is just saying, here are the products available to you. Here are the carbon contents of those products. Here's the cost of them as well. Do you want to make an informed choice? And if you do have carbon targets or commitments, that may mean that you might be willing to pay a little bit more for something that's 50% less carbon. So I see the role of the GCs and the architects in this space to really be the influencers, not the requirers, and just empowering our owners to make informed decisions.
Hi, Stacy. That was my question. And again, great webinar. I guess my real question is, earlier there was a comment about when it was suggested that somebody switch vendors for reduced embodied carbon product, there were some objections to that. I was curious what other objections people might have heard to making that switch. Is it more of an administrative thing, or requires research on somebody's part, what they don't want to invest in, or those types of things? What's been your experience as to any kind of pushback you've had from people doing this?
I think well, coming from the construction industry, I think that we're risk averse. So anything that's new or requires some level of change is always, I think, harder than it needs to be. But really the barriers that we've seen have been perceptions that it's going to cost more for the material. So that's the first one that we have to break through. And that's just by, again, embedding this kind of carbon data into the cost estimating and bidding process, so you can really prove whether it's more cost or not. And what we're seeing is that it's not at this first level of reduction that is the low-hanging fruit. So cost, then it's time. So how long is it going to take someone to do this work? It's a new tool, those types of things that, it would fall on someone either in the estimating team or a sustainability person that you have on staff at your company. And so it is something you have to learn, but it's quite easy to use. So, I think because it was started through the lens of someone in the construction space, then working with a whole bunch of users to try to make it simple, the barrier to the use is very low too, once you register and just start to engage with EC3. So that one we're trying to break through too, but those are really the two. Oh, and then data. I think, when we started this 2 or 3 years ago, we had some good data, but that data has just increased so much over the past 2 years that we're starting to be able to be able to break through that. Well, we don't have EPDs for these things. That's changing too.
Okay, any other questions? Right. Well, as I mentioned before, I will be sending out a link to this recording as well as the PowerPoint that Stacy was referring to. And if you notice, Stacy has her email for building transparency available, or excuse me, the website for building transparency is up on the screen right now. Please, do take advantage of the fact that it is available to everyone and check it out. Stacy, we appreciate all of your time in your presentation here today, and really appreciate the information you've brought to our CURT community.
May I ask one more question?
Absolutely.
Sorry to interrupt. Have you noticed any competition among producers saying that they're seeing that they don't get on board with the EPDs and things like that? So that's becoming, how should I put it? It's becoming more and more obvious that this is the way to go, and therefore everybody's sort of realizing if they're going to stay competitive, they're going to have to get on board.
We are seeing that, and those are slides I typically share at the end. I mean, I think so. This is just user. So the trend is this kind of chart for anything to do with use and production of this data. And there are so this is users. We're at 25,000 users now of the tool. These are the projects being put in the tool. But in terms of EPDs, this is what's happened with concretes since we started. So we were down here in 2020. And then we were able to do things digitally, and just the amount of EPDs we have for things like concrete, and the way the map is turning more and more blue. This is an old map. If I went to the current one in the tool, there's blue all over the place in this map. It's all across Washington now. It's coming across all these major urban centers, and the data just continues to increase. This is the increase of all of the EPDs in the tool since we launched it. But it's because of the fact that there's large private owners, there's architects, engineers, contractors, and there's public policy. They're all pointing to EPDs as that transparency mechanism that is required to do this work. And that's not going to slow. That's going to increase over time. We're seeing it right now, just in the states that are looking at this, the federal government. And then again, I think the UN example of this happening even at the global level.
Thank you.
And Stacy, there is a comment here. Actually, it looks like a question. Is it hard to compare apples to apples on EPDs since folks may use different assumptions in software and may not use the same form of a product, say like a faced or unfaced product?
Yeah, so that's why in EC3, 2 things are happening. The LCA standards are kind of globally standardized. So the way that you actually do the LCA assessment is going to follow ISO or EN. There are different data inputs, different data sources for some of the average factors that might be used. So there is a little bit of uncertainty that could be applied there. At the product level, product category rules do ensure that manufacturers that are following the same PCR are disclosing the same scope of information and the same underlying data sets. So there's things like Tracy and CML that have to be disclosed. So in EC3, you can search and filter by all of those things. You can filter by PCR. We disclose the impact method. We apply uncertainty to the numbers, so you can see a little bit of blue squishy stuff around the disclosed number. So we're telling you that there is a little bit of uncertainty. Comparatively, you need to look at that uncertainty when you're looking at the two products next to each other. And we're also working towards standardizing the data and the PCRs globally so that some of that would go away. Again, that perfection is not there yet, but we know enough and we are disclosing it transparently that you're still making informed decisions. The good thing about concrete here in North America is that they're all following the same PCR and the same method. So, you know, we've looked at the two different tools that are used. We've got one concrete supplier that's done an EPD in both, and it's a rounding error in terms of how different they are. So it's there are differences. We need to be able to filter down to make fair comparisons, which EC3 allows. We have filters for things like faced or unfaced. And if you're talking about gypsum board or insulation, the filters are there that you can filter down to like products to make sure that you're getting to the things that are meeting the same performance.
Okay. Do we have any other questions for Stacy?
Oh, the one thing I forgot, I'm going to just go since we have a couple minutes.
Sure.
I forgot to share this one. I guess it's probably important if it's again the construction sector. We do have a couple of integrations that are live now. One with Costex, if you use that for estimating, where you can set an EC3 rate library and just have a carbon column in your cost estimate. So a direct kind of integration there with Costex. And then we also have an integration with Procore where you can log into EC3 through Procore, do your project work, and then export the report back to Procore. Both of those are going to have a second integration that goes even deeper in terms of how you can move the data back and forth. But if you are using those softwares, I would urge you to reach out to get the demo of how to engage with EC3.
Great. Thank you for that additional information. And again, thank you for the entire presentation, Stacy, and thank you all for attending. If you have any questions, feel free to reach out to me. Then, you know, I can also make sure that that information gets over to Stacy. And we thank you for joining us today, and I hope you have a great rest of the day. Thank you so much.
Absolutely. Thanks for the questions.